All right, for our next problem here, it's not going to be much more complicated than the first problem. However, we've been given masses of the two gases here rather than their number of moles, so that'll just add one step for us. Because ultimately we're going to use again that the partial pressure of neon, that the partial pressure at argon is equal to the mole fraction of argon times our total pressure. We'll just have to do a little bit more work here to figure out the mole fraction. So let's take our 1 gram. We'll start with argon. And all we have to do is, and I went ahead and looked these up, the molar masses of the two gases. 39.95 grams of argon. 1 mole of argon. Okay, so my number of moles of argon is equal to 0.025 moles. Okay, we need to do the same thing with the O2. There's also exactly 1 gram of O2 gas. Okay, for this one it's 0.031 moles. So that's my number of moles of O2. And now we need to do this mole fraction of the argon, and that's going to be equal to the moles of argon over moles of argon plus the moles of the O2. 0.446. And now we can finally do our calculation. So pressure of argon, 0.446 times the total pressure, which is given way up there somewhere, 1.0 atms, and so 0.446 atms would be the partial pressure. And it ended up being the same as the mole fraction because total pressure here is 1. So 1 times mole fraction gives us a partial pressure of 0.446.